Okay, Saxon 4 math students, we are ready for lesson 89, mixed numbers and improper fractions. So let's go straight to some examples. Example 1 tells us to draw circles to show that 2 3/4 equals 11/4. So we're going to do that. We're going to do it with circles, but then I happen to know that Common Core standards are going to ask you a lot about fractions on a number line. So we're going to do it two ways today, okay? First with circles, 2 3/4 and 11/4. Okay. Okay. When you have your numerator larger than your denominator, it's considered to be an improper fraction. That means there's a better way to say this. And the better way to say this is 2 wholes and 3/4 of another whole, 2 3/4. So I'm going to show you why. If we do 2 whole circles, and those circles are divided into fourths, I can tell because when I get around to my fraction, wants to also be in fourths, and I color in 3 of those. On these others, I get to color everything in. Got 2 holes colored in, 2 whole circles, and 3/4 of another circle. But if I go through and I count each little piece, which is called a fourth because I have divided them into 4 pieces called fourths. If we count them, let's see what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We actually have 11/4. Okay? On a number line, what this might look like, if we know that we have to start at 0 and 1 and 2, we'll put this as 3. We know that we have to split each section between whole numbers into fourths, just like we did with the circles. Okay, so I do a half mark and then my quarter marks. Now you can see that there are 1, 2, 3, 4 sections from 0 to 1. And 4 sections from 1 to 2. When it's an even number for your denominator, you can always start by just dividing it in the middle and then think, oh, I need 2 pieces on this side and 2 pieces on this side to equal 4. Sometimes it may ask for sixths, so you'd have to have 3 pieces on each side, but it's easier if it's an even number, just divide it in the middle first. So now we have 4 sections, fourths, between each whole number. Now if I put a point at 2 3/4, so here's past the 2 and I have to go 3/4 past that. Okay, 1/4, 2/4, 3/4. So my point would be here. So this does stand for 2 3/4. I can still illustrate that this is 11/4 by showing the total jumps from 0. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can also show that that's the same as 11/4 on a number line. And look at their beautiful illustration. Okay, so let's do some more practice. Again, we'll do circles and number lines also. We have to show 1 3/4 equals 7/4. So I'm going to draw 1 whole circle, and I can shade that whole thing in. I'm going to do 3/4 of another circle, so I have to divide it in fourths and shade 3 of those. And I have to show that this is the same as 7/4. Okay, so let's count how many slices. Each one of those is called a fourth that we have. 1, 2, 3, 4, 5, 6, 7. Great. Now let's try the number line for this one. We always start, usually, at 0. Then we'll do 1, and I need to go as far as 2. Okay? And I know I need to divide this in fourths, so again, I'm going to halve, and then halve the halves, and I've got fourths. I need to plot my point at 1 3/4. So here's past the 1, now 3/4 past that 1. 1, 2, 3. So here's my point that stands for 1 3/4. Now let's illustrate how that's actually 7/4. 1, 2, 3, 4, 5, 6, 7. And you can see we end up at the same point. Now 2 1/2 equals 5/2. Okay, so this time I get to draw 2 whole circles. And those are all shaded in. Oh, my pen is going crazy. I have figured out that if my phone is next to my pen pad or my wireless mouse, I have to move all wireless devices away from my pen pad or it jumps around like crazy. And then I have to do half of another circle. So I'm going to divide it right in half and just shade in one of those halves. Now I have to illustrate that this is the same as 5/2. So to do that, I'm going to kind of highlight that and divide everything in halves. Now let's count the ones that are shaded. 1, 2, 3, 4, 5. So 2 1/2 is the same as 5/2. Now let's do that on our number line. Starting at 0, 1, 2, 3. This time I only have to mark halves. Hey, that's easy. And I plot my point at 2 1/2. It's kind of off, isn't it? Now I have to illustrate that this is the same as 5/2. So let's count my jumps. Here's a half, there's 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So 2 1/2 ends up to be at the same place as 5/2. And one more. 1 1/3 equals 4/3. Make my whole number a little bit bigger. Okay, I get to do one whole circle and then a third of another circle. And I like to kind of split mine into, I like to draw a Y that gets, fairly close. And I get to color in one of those. And then to illustrate, I also have to divide this one into thirds. And now we're going to count the thirds. 1/3, 2/3, 3/3, 4/3. So 1 1/3 equals 4/3. Okay, and on the number line, 0, 1, 2 is as far as I need to go now. Now I have to divide them into thirds, so I can't immediately go in the middle. I have to make sure I have 3 equal sections. So when I make 2 marks, I know I get 3 sections. And if I were to make 4 marks, I'd get 5 sections, etc. Now I have to plot my point at 1 1/3. So past the 1, 1/3. So this point stands for 1 1/3. Now let's show how that's 4/3. Here we go. 1/3, 2/3, 3/3, 4/3. So 4/3 is the same as 1 1/3. And a little bit more expanding on the improper fractions. Let's try this one. So I could do all those drawings and I could do the number line, or I could do this test. Now, when you read this, what this actually means, if you were to put this in a calculator, you would start with the numerator. You would say 12. Then you would hit the division symbol because this means divided by 5. Okay? So, I mean, we could actually do that, 12 divided by 5, but it's pretty easy to do in your head. How many groups of 5 can you get out of 12 without going over? You can get 2, can't you? Because 2 times 5 is 10. And however many's left over, I would have 2 left over, is the numerator. And your denominator stays the same, okay? So 12/5 is the same as 2 2/5. Okay, let's try another one of those. Oh, let's see. How about 13/4? This means 13 divided by 4. How many groups of 4 could you get out of 13 without going over? You could get 3 because 3 times 4 is 12, right? And the difference between 12 and 13 is just 1, so you'd have 1 left over. And what did we say about the denominator? It just stays the same. We were working with fourths, we stay with fourths. So 13 fourths equals 3 and 1/4. Okay, let's try one more. How about this? How many groups of 3 could I get out of 19 without going over? I could get 6 because 3 times 6 is 18, and that would give me 1 left over. And what about the denominator? It stays the same. So today you've also learned how to take an improper fraction and turn it into a mixed number. That's kind of the same as when you have something like this, 4/8. It's not the best way to leave it like that, is it? We've learned that 4/8, we should really say 1/2. Well, when you run into an improper fraction like this, it's not okay to leave it like that. It's better to rewrite it as a mixed number. Okay. Now let's go back, and I know you need to check your written practice for 88. So hit pause as you check 1 through 7. Hit pause as you check 8 through 11. Hit pause as you check 12 through 20. Hit pause as you check 21 through 28. And hit pause as you check 29 and 30 in the early finisher if you did that. Okay, now we're going to do some mental math. Here we go. You're thinking 25 times 1, tack on those 3 zeros, and you have 25,000. Okay. Okay, for 58 plus 35, I'm going to do the little borrowing trick. I know 58 needs 2 more to become 60. So if I borrow 2 from that 35, it really becomes a 33. So we have an easier problem now. We have 60 plus 33, 93. Alonzo needs to collect 25% of $40. What is 25% of $40? Well, first of all, you have to know that 25% is really a fourth, 1/4 of 100%. Think, a quarter, it's 1 out of 4 quarters for $1, right? Okay, so we're going to divide this by 4 since 25% is a fourth of 100%. So think, $40 divided into 4 groups would give us how much? $10. All right. Time. What day is 71 days after Wednesday? Well, each week has 7 days. So if we were talking about 70 days after Wednesday, that would be 10 weeks, right? And we would be back to Wednesday again. But this says 71 days. So that would be Thursday. How many feet is in 6 yards? This is helpful for all of you football players or football fans. In 1 yard, there's 3 feet, right? So think 6 yards times 3 feet, 18 feet. The book cost $6.75. If Dana paid for the book with a $10 bill, then how much change should she receive? So let's start at the $6.75 and count up. I know I need 1 more quarter to make it to $7. So I'm going to keep that quarter in the back of my mind, and I'm going to think the difference between $7 and $10 is $3, and then add that quarter on, and she should get back $3.25. Okay, we get to estimate now. The total cost for 6 picture frames was $41.94. Round this amount to the nearest dollar. Okay, so let's do that. Is it closer to $41 or $42? It's closer to 42, isn't it? Then divide by 6 to estimate the cost of each frame. So think 42 divided by 6. So think of your 6 multiplication facts. Okay, 6 times what's 42? It's 7. So each of those 6 frames would cost about $7. Calculation. The square root of 1. Okay, this is funny. If you have a square made of tiny squares and it uses only 1 square, then what's the measure of one of those sides? It's 1, isn't it? So here we have square root of 1 is 1. Times 1 is 1. Divided by 1 is 1. Minus 1 though, 1 minus 1 is 0. Plus 1, final answer, 1. Problem solving. Here we have a nice Venn diagram. Let's read the labels first of all. We've got multiples of 3 fit inside this circle, and even numbers fit inside this circle. So you can see so far we have example 6 is a multiple of 3. That means when you count by threes, you're going to say 6 at some point. And 4 is an even number, but it's not inside the multiples of 3. You do not say 4 when you're counting by threes. And 1 doesn't fit into either one of these categories, okay? So let's read the problem now. In this Venn diagram, the circle on the left stands for multiples of 3. The circle on the right stands for even numbers. The number 6 is both a multiple of 3 and an even number, so it's placed within the space created by the overlap of the two circles. The number 4 is placed within the circle for even numbers, but outside the overlap, since 4 is not a multiple of 3, and the 1 is placed outside both circles because it is not a multiple of 3, and it's not even. Okay, so I had just said all that, and now I've said it twice. Copy the Venn diagram on your paper and place the numbers 9, 10, 11, and 12, but we're going to do this mentally, okay? Let's look at 9. Is 9 a multiple of 3? 3, 6, 9, dun, 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 dun. Well, yes, it is. Okay. Is it an even number? No, it's not. So 9 will fit in this area. Okay. Now let's look at 10. Is it a multiple of 3? 3, 6, 9, dun, 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 12, 15, 18. Nope, didn't say 10 when I counted by threes. It's not a multiple of 3. Is 10 even? Yes. So it's going to go like in the same section with 4. 11. Is 11 a multiple of 3? 3, 6, 9, dun, 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 12, 15, 18. No, it's not. Is it an even number? No, I don't hit it when I count by twos. So it's going to go in the same area outside of both circles, just like the 1. And 12. Let's see if 12 is a multiple of 3. 3, 6, 9, dun, 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 dun. 12, 15, 18. Yes, it is. Is 12 even? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yes, it is. So 12 is going to go in the same section as 6. And we are finished.